Good evening, everybody. So, welcome to the part 2 of the assignment. So, basically, in the part 2 of the assignment, I was assigned with these values. So, basically, we have to calculate the unknown concentration of the DNA. So, basically, these was the table that was assigned to me. So, I'll copy this data into the new Excel sheet. So, I'll write Excel. Yes. Now I'll copy this new data here in the Excel sheet. Okay. Yes. Okay. Now we're ready. So basically, to calculate the unknown or to calculate, and to plot the graph, we need to have like three equations with us. That is the first equation that we all know. That is A is equals to E into B into sorry B into C, and the second equation that is used for the linear graph or the linear line, that is y is equals to mx plus c, and the third equation that is gonna be used, that is for the extinction coefficient, and the equation for extinction coefficient is m is equals to e into v. So these three equations are the equations that we are going to use for today's calculation and graph plotting. So basically, before we begin, just for the sake of just to simplify things, I'll just write the what A, Y, M, E, B, and all these letters stand for. So basically, let's start with the first equation. So A, that is equals to absorbance. B, the next thing is E. E is equals to extinction coefficient, and B is equals to path length. That was LENGTH. Okay. So basically, path length was given to me here. Okay, where is my rule? Yes. The find extinction coefficient where path length is 0.05 centimeter. It was already given to me, so it's like constant for everybody. So yes. So path length was already given. Now C is equals to extinction coefficient. Sorry, C is equals to concentration. Yes. So this letters denote A is equals to absorbance, E is equals to extinction coefficient, B is path length, which was constant 0.05, and C is concentration. Now for the second equation, we will write y is equals to not y, I'll simply write m, because m is important. So m is equals to slope, as we all know, and c is the intercept, or I can say, because C and C will be same, so I'll write it as capital C. So capital C will be the intercept, and this was for the second equation, as you can see. Now for the third equation, it says m is equals to EB. So basically, m again here is the slope. M here is the slope. E is equals to extinction coefficient. And B, as we all know, is absorbance. Sorry, it's B. So B is like path length. Sorry, my bad. Yes. So basically, these three letters, what all these letters denote in the three equation I've already mentioned here. Now we come to the plotting of the graph here. So basically, for the plotting of the graph, what we'll do is I'll just shift these values because I'll have to plot my graph. So I'll copy this, Control C, and I'll just paste it here. Yep. I'll do the same for this, Control C, and I'll paste it in Control V. Yep. So basically, all this will be deleted. Yes. Now for the plotting of graph, what I'll do is I'll take all these values. Now I'll go to the insert option and then I'll click on the charts. On the charts, I'll click on the scatter link. So while I click the scattered link, as you can see, I got my graph, and I'll just adjust the graph now. Now after adjusting the graph, click on the plus sign. After clicking on the plus sign, click on trend line. As you can see, my graph is already straight. Yeah, it's linear. Yes, you can see. I click on more options, and in more options, as you can see, you can select anything according to your own personal preference, but I have selected linear because it was needed and required. So basically, before you start with anything else, let us set the intercept. So the intercept should be at 0. Now I'll click on display equation and display R squared value on chart. So basically, as you can see, I got my y and x value. So basically, r square is equals to 1. So as you can see here, I'll click on axis titles, and according to the titles, just a second, just let me, okay, yes. Now what I'll do here, axis titles, yep. So I'll now rename these axis titles, and the y-axis is my concentration in nanogram per, yep, okay, and my y-axis was concentration, and my x-axis would be DNA absorption or absorbance. So as you can see, I am done with the graph here now. So now when I come to the calculation part, so basically I have to calculate the unknown value. So in order to calculate the unknown value, what we need to do is we will write the equation y is equals to so just a second. Yes, so for calculating y, so we need y is equals to, we will write 449.4x. yeah, in the next step, as you can see, y is as you can see it from here, my intercept value is y is equal to 449.4x. so I wrote this value here. Now in the next step, what I'll do is I'll write an equals to, that would be 449.4 into where is the into sign? Into 0.7. After multiplying with 0.7, I get this value, and that is 314.58. so basically now I got my unknown value. So I'll change this unknown value. So I'll copy this value here instead of the unknown value, and I'll paste it here. So I got my unknown concentration, and after getting my unknown concentration, I'll delete this. Okay, yes. So now, yeah, so I was telling, so yeah, basically I calculated my unknown concentration. Now after calculating my unknown concentration, I'll again plot a new graph. So in order to plot a new graph, this time I'll take these values, and then after taking these values, obviously I'll go to insert and click to scatter. Yes, after clicking the scattered graph, as you can see, I got my scattered graph, and I'll just put it here. Let me just adjust it. Just a sec. Yes, I adjusted the graphs, and as you can see, I got a new graph. I'll click on access title. Not now, sorry. Okay, after getting this, what I'll do is, as you can see, now I've calculated this value, so the graph is complete now. But in order to find the extinction coefficient, in the second graph, we are finding extinction coefficient. So basically, to find extinction coefficient, what we need to do is, because as we know, extinction coefficient cannot be like, extinction coefficient cannot be calculated like this. So in order to calculate it, we need to reverse the values, or like you can say we have to swap the values. So in order to swap the values, what I'll do is I'll just go to select data, and then I'll just click on edit. After editing, I want my x axis to have concentration, so I'll click on concentration, and my graph is there. Now in the y-axis, I want my DNA absorption, so I'll click on this, and after setting the x axis and the y-axis, then click on OK, and then like this you will find a change in your graph. Then obviously click on access titles, and yeah, we need to rename the access title. So after renaming the access title, what we need to write here is, as we just swapped, as you can see, this is the first graph and this is the second graph. So in the first graph, you can see the concentration was along the y-axis, but now here the concentration is along the x-axis. So basically I'll again go to access titles, and then I'll rename it. So this time my concentration is there on the x-axis. Okay, nanobron. Okay, yes. Oh, sorry, please bear with me, I'm not good in typing, so yeah. Oh, sorry, what's this happening? Oh, this one is not working. Okay, I have to do like okay, yeah. Yes, so I adjusted the concentration on like in the I renamed my x-axis, and now I have to rename my y-axis. So my y-axis here would be the DNA absorption. Oh, what okay, what happened? Okay, absorption. Okay, yes, as you can see here, now we just got the graph, and now once again we'll click on plus sign, and now we'll go to trend line, and then we'll click on more options. Okay, we got it. And now first of all, please click on the set intercept button, and now we will set the intercept to 0, because if we want, then yeah, I just practiced this and I didn't set the intercept once, and I just got my value to be something around 449.4x minus 2e, something like that. So it was basically an error. So so to avoid errors, just set your intercept to 0 always. Now click on display equation and display value on r squared value on chart. So as you can see, we got our value, and after getting the value, yes, so basically after like getting the value here, what we'll do is, okay, let me adjust the graph. Okay, this is concentration. So oh shit, silly mistake. Oh, it's not even going to get undo. So I guess I really have to it's alright, I'll do it once more because so what I did was this, and then I clicked on scattered. Oh, scattered. After clicking on scattered, I did this, and then I swapped the values. Yep. So basically I'll go to select data once again and edit. So yeah, in my x-axis I want my concentration, so it would be like this, and on my y-axis I want my DNA absorption. Yes. Yep. Now I'll click on OK button, and now I'll see yes, my graph has been swapped, and I'll click on axis title once again. This would be obviously concentration. Control C. Backspace, Control V. Okay. Oh, DNA absorption. It's DNA absorption, and in this it is concentration, as you can see. Concentration. Yep. Ng by U. Okay, I got this. After clicking on this, go to the trend line section. Click the trend line once again, then go to more options. Okay, set the intercept always. As you can see, I've got my equation. Now I'll be solving the extinction coefficient. So basically for extinction coefficient, as said, the value, the equation was m is equals to this. I'll copy this instead of writing, that would be much better. Or so after getting this, that would be E is equals to what I'll do is what I'll write. Okay, I got 0.0022 x. Yep. And now I'll go to now I'll do is equals to 0.0022 divided by b, because b was our path length here. So path length was constant 0.05. So obviously I got my answer as 0.044. So this is the answer for extinction coefficient. So basically, as you can see, just a sec. Yes, as you can see, this is the answer for extinction coefficient, and plus the value, the unit for extinction coefficient is Ng. Well, inverse, to be honest, but I don't even know how to write inverse. Okay, inverse -1 centimeter -1. Okay, but this what happened? Oops. Okay, yes, I got it. Yes. So this is our answer. So as you can see, I have calculated the extinction coefficient, and by using these three formulas, that was the DNA the absorption, the intercept, or you can say the linear equation, and the extinction coefficient. By using these three equations, I've calculated it. And for the first graph, I calculated my unknown value, as you can see here, and then And then, as I said in the first graph, I calculated my unknown value here by using that formula of by formula using a and the first two formulas, and then the second graph that I calculated was to find the extinction coefficient, as you can see here. And for the second graph I swapped or reversed my values because that was not coming out to be appropriate. So in order to calculate extinction coefficient, you need to reverse the values so that you can find it. So I reversed these two values, and you can see the difference between both the graphs. And one more thing that I just forgot, I need to rename this as well. So basically here it would be DNA absorption, and here it would be concentration, and here it was DNA absorption. Yes, so as you can see now, here everything is perfect now. So yes, this was the this was the end of our assignment, and yes, that was it. So thank you so much for joining, everybody. I hope you understood. Thank you.